Okay, hello everybody. Today we'll continue the topics that we started last week. But quickly review what we did last week. We started building our scenes menus and things like that, right? Making transitions between scenes. This week what I want to do, I want to play a little bit with physics and with collision detection in physics. Like 2 weeks ago, we kind of messed up the whole Pong game that I started building here, mixing moving objects with transitions and adding physics at the same time, right? Then we had this situation when we're expecting objects somewhere, but it wasn't there anymore, and things like that, right? So we will fix it today. Not exactly working with the same project, but I will show you step by step how to detect collisions when you work with physics. Right, so let's create a new project. Game project. Can you see that? You can't. I will turn out the light. That's a little better. So I will change the resolution. GA. And just making sure that we still share the screen. Sorry. Week 7. Swift, it's Sprite Kit. Next. Okay, we're in. So first thing, let's remind ourselves how we can create transitions between scenes. So let's assume that the scene that we have right now, game scene, it's there are two files connected to this scene, right? It's SKS and Swift. SKS allowing us to build everything using the graphic interface. Swift is a class, implements the class connected to the SKS file. You can verify that going to the inspector, to identity inspector. You should see, where is it? You should see it here. Not sure why we don't see it. Default. Hello. And we have these two classes. Now, if we want to add more scenes, you can do right-click, new file. And now we can add Swift file to implement the behaviors, right? To implement the scene in terms of the code. Or we can go to the resources and we can select Sprite Kit scene. It's this one, right? So depending what you want to do, depending how you want to implement your scene, you can go with the Swift file alone and add everything using the file, right? Using the code. Let's create a scene using resources. So it will be called play scene. Create. I will also create Swift file source Swift. It's also called play scene, same name. Right, Git. This is the thing that we have to import to have access to all the classes, right? To all to the whole library. And in Swift, we'll implement new class. It will be a subclass, right? Play scene will be a subclass of SK scene. What we'll do in this class, we'll discuss in a minute. Right now, let's save this. Let's think what we want to add, what we want to modify in our main, in our main scene in game scene.sks and game scene.swift. This game scene will be our main menu, right? It will be our entry point. So what we want to do basically, we want to, you look at the scene right now, nothing there, right? It's empty. So everything is added in the Swift, in the game scene.swift. What do we add there? We add the label node saying hello world. Let's change this to start. And then with each touch, we add this model of the plane to the scene, and we don't want this to happen, right? So I will remove the body of touch begun. So we play it right now. We'll have scale it down. That's our starting point, right? Now what we want to do, we want to detect the tap event in the scene. How we can do it? We can do it with touch begun, right? Touch begun, we have to define two things. First, the scene where we want to go, and second, what is the transition, right? The animation during the transition. So the first thing, scene, right? Let scene be equal to SK scene file named play scene. This will read SKS file and will create the scene. You can also instantiate the class, right? Play scene implemented in Swift. The second thing, let transition be equal SK transition. And now we have to select from the list what kind of animation we want to do, right? Things like door open, door close. Doors open horizontally, and then you say how long the transition should take. Say 1 second. Now this can be used when we make a transition, and we make this transition asking the view present scene. Right? And we're saying what is the scene and what is the transition. We have to add the exclamation mark either here when we create the scene or here where we use the scene. One of those places we have to add exclamation mark because this constructor is the constructor that may fail, right? If the file does not exist, it will return nil. So the type of this scene here is SKScene optional, right? And we have to unwrap it. And now when you play it, you tap it, it opens the door, and it presents the second scene, right? Now you can use this mechanism in other places in your game, right? You can, the same way you can make a transition between levels in your game, right? Going to game over screen, going back to the play scene and so on, right? Okay, let's talk a little bit now about physics. It would be nice to have some. Let me check if I have here any images. My downloads. Nope. Okay, let's download some. Say ball PNG. Just show you quickly how we can add something to our. That will be good. It has transparent background. How we can add stuff to our project. The easiest way, you can just drag and drop. Make sure that you select this copy item if needed. Otherwise, it's just a link to existing item somewhere on your disk, right? If you move the project, let's say you submit it on Blackboard, I'll be missing your resources, right? So make sure that this is checked. Finish, and we have a football PNG added to our project. We can add it to the scene. Well, you can, of course, add this stuff to assets, making sure that you have different sizes and stuff, right? But you can also include it in your project directly. Now let's go to the play scene, to SKS. How I can use it, I can just drag and drop this thing to the scene, and it will create object in my scene. I can set it somewhere. But this is static, this is just sprite. How do I add physics to this thing? I have to select my object. Then here, I have the attribute inspector. First, I can set some more meaningful names. Let's say ball. And this is important because then you can find this object in your scene based on the name that you set. Right? So if your name is meaningful, it will be easier for you. If it's just a random number, you will have to remember that. And when you scroll down, at some point, you will find physics definition here. By default, body type is set to none. You can select from the list 3 things. There is a bounding rectangle, bounding circle, and alpha mask. I think bounding rectangle and bounding circle is obvious, right? Alpha mask is pretty useful if you have something that is of more complex shape and has a transparent background, because then it will use the alpha channel in your image to detect the shape of your sprite, right? So instead of big rectangle or something like that, you will have something more, something closer to the shape of your actual image, right? In this case, I will select bounding circle. Okay. Now you can select if the body is dynamic. It's a ball, we want it to be dynamic. So we'll leave this. If we allow rotation, and now it depends, right? For the ball, I don't care. Even it should rotate. But let's say if you're building a platformer and you have your character, you don't want your character to rotate, right? You want it to be fixed in terms of the position, the orientation, right? So you can then you can deselect this one. You can pin it to the specific position, and you may decide if it's affected by gravity or not. Right? I'm leaving this this checked. If I play my game right now, my ball will fall. What else would be nice? It will be nice to have some kind of floor. So I will add floor to my game. Again, I want to add some physics to the floor. In this case, I can select bounding rectangle or alpha mask. And I don't know if you can see that alpha mask is more, it's closer to the shape of my rectangle, right? What else? Because this is floor, where is it? Floor. I want this floor to be static. I don't want it to rotate. And to be honest, I don't want it to be affected by gravity. I want this floor to stay in the same position all the time. Right? It's a floor. It shouldn't fall down. And so I have a floor. Let's play it. It seems that my floor is a little bit tilted, but that's fine. Sorry. Now, physics the engine will take care of interaction between those two bodies, right? So the ball will fall on the floor, won't go through it. That's all built in into the engine. But I may want to do something when these two bodies collide. How can I detect that they collide? First thing you may want to ask is really, how do I refer to those two components in the code? Let's declare two variables in our placing SK scene. First will be ball, SK node, and second variable will be floor, will be also SK node. Then we'll override function with move to view. So remember, before, this is the function that is called when the scene is displayed. And that will be also a good place to get these references, to get ball and floor from the scene, from the SKS file. And how to do it? Well, ball will be equal to self dot child node with name. That's why I said that we have to use something meaningful as a name, because now we can find our nodes based on the name. Ball floor self dot child with name floor. So that's one thing. You can access elements. You can access components. Now, SpriteKit provides you a delegate that can be used to detect collisions, to detect contacts. And this delegate is called SK physics contact delegate. What is delegate? It's a protocol, right? It defines a method that you can implement to receive notifications. In this case, this method is called begin contact. And in this method, you receive a contact object. And contact object has information about what kind of collision, who is colliding, the force that is generated during this collision, and so on. We'll look into this next week, well, after the break, in 2 weeks. Right? But specifically, you can detect what are the bodies that are colliding. So for example, you can check if the body that is colliding the ball. It can also be the second one, right? So else if contact dot body e dot node name equal ball, can say that it's B that is colliding. Is it enough? Well, if I play it right now, nothing really happens. You see that the log in the background is dormant. Nothing happens because this delegate is not signed. It's not assigned to anything. To make it working, we have to assign it to the world. Physics world, contact delegate equals self. And I think we have to say that this scene is implemented by play scene class. Okay, no, one more thing. We have ball, we have floor, they're all set up except for one thing. Both objects, if you look at them, they have physics body, and the physics body has some masks defined. So there is a category mask. I think it will be easier to look at them elsewhere. Not in the code, but in the SKS file. So let's select a ball, and let's see the inspector. When you added the physics definition, so you defined the physics body, a few things were added. You have a category mask. Generated here. The category mask defines a class of objects in your game, like enemies or bullets or walls, right? You can define objects that will collide with them and will generate certain events, and other collisions will be ignored, right? You will not be bothered by other collisions, right? So you can define a contact mask for the ball, and you can say, what are the objects that I want to be notified when ball is colliding with them, right? And what you do really in your code, you can do it manually there, but in your code you can you can say that your ball physics body dot contact test bit mask is equal to floor physics body category bit mask. So you're saying that you will collide sorry, that you will collide with with the category that is assigned to the floor. Right now, it's really the same thing. If you look into the SKS file, they're both the same. I will show you that. So this is the category mask for floor, 429, 496, 7295. And the same number is really used for ball. You can modify that. You can you can change those numbers. You can assign different numbers for different classes of objects in your game. Then you have to make consistently changes in your implementation. ID inspector. So right now we are saying that we want to be notified when ball collides with the floor. Let's see if it works. You see that here we have notifications that ball has a collision with the floor. And what you can do, you can ask some, you can add some force, you can move the ball, you can bounce it back, whatever you want, right? Say we'll do var ball ns node actually we can take this ball right away. And we can do it here, right? So ball that contact dot body A dot apply impulse CG vector, and you're saying vector make 1 10. The same thing here. Each time it collides with the floor, it will be bounced up. It's not. Now, if you want to be notified about more than one category in terms of collisions, you have to concatenate them using the binary OR operator, right? So let's say you have floor and enemy it will be category bit mask for floor or category bit mask for enemy, right, and so on. Basically, what it does, it combines them. It makes binary OR on these two numbers, and the bits that are set defines which category is taken into account when we collide. Okay, so those are the things that I wanted to show you today. The rest of the lab, you have work time for your assignment. I know that labs should be open during the reading week. I will verify that, and I will post information specifically about hours and days on Blackboard. But you should have access to labs during the reading week to finish the assignment. Right? Also, remember to send me emails about your groups for the group project. Right? That would be, yes, names, the student numbers, names, and CRN. If you're in the same group, that will be helpful, so I don't have to jump and look between two groups where you are. Right?
You have that this week?
Yes. Yes. So after reading week, we can start really talking about project, the topic, the type of the game that you want to do. Then the first milestone is the game design project document, right?
That's the week we get back.
Yeah. Yeah. You have the detailed spec posted on Blackboard. Okay. So what I will do now, I will stop the recording.